Okay, so this is topic 10, current of electricity. So we've done electric fields. Essentially that's where we set up a energy source to create a current, and then we're going to look at what happens with that electric field. So just some circuit symbols you need to know. Okay, you got the cell, battery, switch, lamp, ammeter, voltmeter, resistor, and so on. Okay, some of the ones that you may not be used to. We have the LED. Okay, so that's just that triangle with that, and it releases light. Two arrows there. Oh, there we go. Thermistor is a resistor, and it changes with temperature, and that's why it's got that little line through it. Diode. Look at the LED here. That part there is the diode of it. Light dependent resistor. So that one put over here. That is just a resistor, and how you can see the light here leaving the LED, if I just draw some arrows going in, it means that light coming in changes that resistor. Potentiometer rheostat is just a resistor with a sliding contact. Variable resistor, usually we just draw that as a resistor with an arrow going through it. Motor, there's just a circle with an M in it. You can play more and see more at the circuit pairs game. Defining current again. Remember, current is actually a base unit, so it's a defining physical quantity in its own right. Okay, it's defined in other ways. But remember using the dictionary and define. You can use a dictionary to define the current, but essentially it's the rate of flow of electric charge. Okay, so symbol I formula, remember, is going to be I equals Q over T. It's actually the defining formula really of charge. The unit, remember, is the ampere. Measuring current, what is this device? Well, this thing's actually a multimeter. But in this particular setting, from there to there, okay, it's actually an ammeter. Okay, in those settings there. Be aware of that. When you use these ammeters, you need to make sure you find out what setting of these three that it's on. Okay, so that you can put down the right units, particularly in your practical exam. Where should we place in a circuit? Always in series. So if you had a circuit like this, you actually need to snap the circuit and place it in. So it actually needs to be put into series inside the circuit. Because it's in the circuit, it has to be like a turnstile. People will, you know, when you go into concerts and so on, you walk through those turnstiles that rotate around. Okay, if you go through one of those, it sort of counts as you go through, but you don't want them to slow people down. So similar thing for an ammeter, has to have zero resistance, as close as it can. How does it behave in series? Well, remember stuff you've done before. Okay, in series, the current is the same everywhere. In parallel, when it goes to a point where more than one wire go away from it, then it splits. Okay, so I1 is equal to I2 plus I3. Okay. Oh. This is actually Kirchhoff's first law, which we'll see in the next topic. Here's an example. What will the current be at points A, B, C, D, and E? Okay, so in the first one there, you don't have to know too much about working out parallel and series resistance yet until the next topic, but the total resistance of this one is 4 ohms, so that means the total current is going to be 12 over 4, which is 3 amps, and it's the same everywhere. Unfortunately, I can't actually see where A, B, C, D, and E are. It hasn't come up in my PowerPoint here. So 3 amps, same everywhere in that one. This one here, depending on what each of these are, it's So this is actually going to be 6 amps there, that will be 6 amps there, that will be 6 amps there. These two junctions are going to add to make 12 there. Then this one here is going to have 12 plus 6, that makes 18 in total. Okay, so here we have potential difference. The definition in the dictionary or video, so I was trying to do one here. Symbol for is voltage, or sorry, V, or sometimes it could be PD. Formula, V equals W over Q. The unit is V. What does it actually mean? It was actually energy converted per unit charge from electrical energy to some other form of energy between 2 points in a circuit. So if we have a voltmeter here and we're connecting it between 2 points in a circuit, so this is sort of a circuit that will just carry on, let's have a power supply there and so on. So if I connect this voltmeter up to there, okay, it's looking at point A and comparing it to point B and finding the difference in energy per charge. So let's say there is 3 joules for every 1 coulomb there, and we have 1 joule for every 1 coulomb there. Should add another resistor to make it true. Then what is the difference? The difference is 2 joules for every 1 coulomb, which is the same as 2 volts. So it's used 2 joules for every 1 coulomb to get through that resistance. How do we measure potential difference? Well, this device, remember, is a multimeter, but when you use this setting, okay, it is a voltmeter. And remember, there's actually 2 voltmeter settings here. There's DC and AC. So you hardly ever use the AC. Okay, this one, actually, if you notice there, it actually says millivolts. So you've actually got to be aware of what is on the screen then when you're measuring the voltage. Where should we place in the circuit? Well, remember, it's sort of like, it's got 2 leads, which are essentially like probes going in and measuring a reference between 2 points in your circuit. Okay, so it has to be parallel. How much resistance does it have? It must have infinite, because you don't want current to flow around here.